Good day everyone, my name is Jean Marlwin El Gamboa. I'm the programmer in this group. I'm responsible for making the program and explaining the program in our Arduino.
Good day everyone, my name is Arshad Ajihid. I am one of the designers in our Arduino project.
Good day everyone, my name is Jerovic A. Ballesteros. I am the documentator of this group. I am responsible for checking and managing the Arduino hardware and software, checking the condition of each components.
Good day everyone, I'm Luis Enrico, A. Quintos, and I'm one of the Arduino designers. And together,
We are the Group 4 BGQA TRONIX.
Arduino project number 13. This project is all about an Arduino motor fan project that uses an Arduino to control a fan, typically a DC motor. You connect the motor to the Arduino via a relay or transistor using code to switch the fan on or off. This setup is useful for cooling systems in automated ventilation. So let's go ahead and start the Arduino project number 13.
These are the components needed for the Arduino project number 13, which is the motor fan. First, the Arduino prototyping shield or this will be our main components for this Arduino project. Next, the jumper cable made to nail, used for making electronic connection between the Arduino board, breadboard, and components. They allow signals to power to travel. Next, the 220R resistor. Limit the current going to the LED so it doesn't burn out. Protects the LED by keeping the current at safe level. Next, the mini push button. Act the switch to control the motor fan when it's pressed. It sends signals to the Arduino to activate the relay and turn the motor. Next, the relay module. First, an electrically controlled switch that allows the Arduino low voltage, low current to control the motor, which needs higher current. It isolates and safely power the motor. Next, the 130 motor or DC motor. The main components that converts electrical energy into mechanical motion. It spins the fan blade when powered. Next, the fan blade converts the motor's rotation into airflow, creating the cooling effect like small fans. And last but not the least is the LED 5mm. Serves an indicator light, usually light up when the fan is turned on, giving a visual status signal. Good day everyone, we're going to build the project number 13, which is the motor fan. First, we're going to use the Uno R3 prototyping shield. And then, get the 220R resistor. Put the two resistor in the prototyping shield accordingly. And then, get the push button. And then, get the LED light. And then, get the relay. Put it in the relay inside the motherboard. Tap normally. And then get the motor fan The red one going to the end here. And the black one going to the ground here. And then get the cable end of the resistor from bottom and then going to the ground. Okay. And then put it in the other end of the relay. Going to the 5 volts. And other jumper wire to the top of the relay, second to the top, going to the digital pin number 3. The other cable will be in the left side of the push button pin, going to the 5 volts. And then the end of the resistor, left side, going to the digital pin number 2. And the right side will be going to the ground. And then the right side in the lower ground of the relay, put another jumper wire going to the ground beneath of the bulb. And then that's it. That is the Arduino design for the project number 13 motor fan.
This is the code behind our Arduino project number 13, DIY fan. Int button pin equals to 2. Int button pin equals to 2. Int relay pin equals to 3. Int relay state high. Int button state. Int last button state low. To record the last button state. Long last debounce time equals to 0. Long debounce delay equals to 50. To eliminate debounce time. Void setup. Pin mode button pin input. Pin mode relay pin output. Digital write relay pin relay state. Configure the initial state of relay. Void loop. Int reading digital read button pin. To read the value of button. If reading is not last button state, last debounce time equals millis. So once detected or once detects change of state record time. If millis minus last debounce time greater than debounce delay. This is to wait for 50 milliseconds to evaluate if it is the same state as last state. If reading is not button state equals reading. If different, change the button state. If button state is equals to high, relay state is not equals to relay state. If the state of button is high or pressed, change the state of relay. Digital write relay pin relay state. Last button state equals reading. This is to change the last state of button.
Good day everyone. As you can see, when you push the button, it reacts. The light and the fan turns on, and when you interact with the button again, the light and the fan turns off. And that is the project number 13, motor fan.